All right, today we move forward to section 5.1, graphing linear equations. I have good news. What's the good news?
Couldn't possibly happen.
We've pretty much already done this. There's really not anything new here. So you might remember back a while ago, I might have asked you to graph y equals 2/3 x minus 1. And we have a couple different ways to do this. The first way we learned how to do this was we went ahead and we built a table. And we picked some of our favorite numbers in the whole wide world and plugged them in, and we use those to draw the graph.
0.
0. Okay, I like 0.
Wow. 1.
Close?
Oh,
Oh, those numbers to plug in?
No. Has to go in 3. Negative.
I thought you were giving me the answer that you get when you plug in 0. Oh, no.
No.
When I plug in 0, the answer I get is
Negative
1.
1.
Now, you could use 1 and 2 to plug in for x, but they're not very good choices. Why not?
Because they don't go with that.
Because they don't go with the fraction. What do you mean, go with the fraction? How does 1 not go with the fraction? You're still going to be a fraction. 2/3 times 1 is still a fraction. So what are good numbers to plug in? 3 and 6 and -3 and -6 and 9 and 12 and so on and so forth. Basically, you want to plug in numbers so that you can cancel the 3 out. So we'll use 3 and we'll use -3 maybe. So you plug 3 in. What happens when you plug 3 in? What's 2/3 times 3? The 3's cancel out and you're left with a 2. 2 minus 1 is 1. And then we plug in -3. What happens when I take 2/3 and I multiply it by -3? The 3's cancel out and I'm left with -2 minus 1 is -3. Alright, so this was the first way we learned how to graph linear functions. We plugged in numbers and we got points, and we're supposed to draw our line straight. My line isn't straight, but you get the idea. Okay, we mark our points. There's 0, -1. There's 3, 1. And there's -3. -3 is over here. And if we did everything right, our dots should form a nice straight line. We connect our dots and there's our answer. That was the first way we learned how to graph lines. Then, a few sections later, we learned a different way. So here's the exact same problem, y equals 2/3 x minus 1. What was another way that we learned how to graph that line? Start at the y-intercept. All right, so I jump right to my grid. I started at the y-intercept. The y-intercept is 0, -1. And how do you know the y-intercept is 0, -1? Because it's in the equation. This number right here always gives you the y-intercept. Then what did we do? We use the slope, and the slope is 2/3. So it told us to go up 2. So I start here, I go up 2, and I go over 3. And that would be the point 3, 1. And then if I wanted to do it again, I could. I could go up 2 more, over 3. What would that point be? 6, 3, right? There's 1, 2, 3, 4, 5, 6 dots that way. 6, and then we've gone up 2 more, so that's 6, 3. And that was the quicker, easier way. Once we understood slope and intercept, it was much quicker to just do that than it was to plug in numbers. Okay, so here's what's going to be different today. I might ask you, graph 2x plus 4y equals 8. What's the issue?
It's not set up as a regular slope equation.
It's not set up the way we like it. We like it when we have y equals and then some stuff on the other side. So what would you do? Solve. So you want to solve for y. So this is kind of why we did the literal equations one, the one with all the formulas. We had to get a little practice with manipulating things that aren't all numbers. What we would really like to do to make our life easier is get the y all by itself. What steps would you go through to get the y all by itself?
Subtract 2x.
Subtract 2x on both sides. So 4y is minus 2x plus 8. And then
Divide by 4.
divide everything by 4. Y is negative 1/2 x plus 2. All right, so sometimes we have to do a couple steps to get the y all by itself. Once we have the y all by itself, we know what to do. We draw our graphing grid here. Where's my y-intercept?
0 down 2.
0, comma 2, which is right about here. 0, comma 2. And then how about my slope? Down 2 over 4? That's correct, but I would probably go down 1 over 2 because I reduced my fraction to be negative 1/2.
Oh.
But down 2 over 4 works also. All right, so I would go down 1 over 2. What point is that? Definitely not negative 1, 0. The x is 2 places over, and the y is 1 up. That's the point, 2, comma 1. Yes?
When I was at the math lab, and I had her check over my paper before I took the bath, and one of the times I did subtract the 2x on both sides, and she said you don't subtract because you divide the opposite. She asked me what you do to divide the opposite of times. So she told me not to do that.
Well, you definitely have to subtract that 2x because it's connected there by an add. And the opposite of an add is a subtract. Later on, we divide by the 4 because the 4 is connected by a times, so we have to divide. All right, let's find one more point. So I start here, I go down 1 more, over 2 more. That point is 4, comma 0. That's an interesting point. This one's the y-intercept. What's this one called? The x-intercept. That's where we cross the x-axis. Sometimes you find that by accident, sometimes you don't. We connect, and there's our answer.
3, 0.
I got 4 because I had to go down 1,
Down 2, yes, sir.
and then I had to go over 2. So my x was 2. I had to go 2 more to the right. That put me at 4. Other questions? Okay, what about 1/2 x minus 1/3 y equals 1.
Probably want to start with common denominator.
Probably want to start with a common denominator
Do their fractions.
because there are fractions there. I agree. And we have an equal to sign. We have an equation. I like that. So, what's my common denominator? 6. What are you going to do with that common denominator?
Times 6 and reduce.
Times 6 by what? By everything. All right, we can do that because we have an equation. We have an equal. We can multiply both sides. So we're going to find our common denominator, which is 6. And we're going to take 6, and we're going to times it by everything. And when I say everything, I mean everything. Very one that's easy to forget is you got to multiply the right-hand side, even though it's not a fraction. That's an easy one to forget. You got to multiply everything by 6. What's 6 times 1/2? 3. So that's going to be 3x. Minus 6 times 1/3. 2y equals 6. So again, we see a bunch of fractions. We don't let the fractions freak us out. We find the common denominator. We multiply it by the common denominator. Makes all those fractions go away, and makes life look a whole lot easier. Now what?
With 3 on each side.
Not minus 3, but minus
Minus
3x. Good, minus 3x on both sides. Minus 2y equals minus 3x plus 6.
Wouldn't you add because there's a subtraction sign there?
But what sign is in front of the 3x?
Oh, yeah.
The 3x is a positive, so to get rid of a positive 3x, we have to do a negative 3x. What are we going to do with this minus sign? We take care of that when we do the divide. We divide by negative 2. Y equals 3 halves x minus 3. Watch out for your minus signs there. Make sure you divide everything by minus 2. All right, well, we're in good shape. Where is our y-intercept?
Zero, negative 3.
0, negative 3. Thank you. Y-intercept is a point. It should have an x and a y. 0, negative 3. From there, what do I do?
Go up 3 over 2.
Go up 3. 1, 2, 3. And over 2. 1, 2. What point is that right there?
0, 3, or 3, 0.
2, 0.
Wait.
It's
2.
2, 0. Because it started at the origin, it's 2 straight over, and there's none up and down. And then I can do it again. I can go up 3. 1, 2, 3. Over 2. 1, 2. Where am I now?
4.
4, 3. How'd you get 4, 3? Well, you started here, you went up 3. So if you start at 0 and go up 3, that puts you at a 3. And you started at 2, you went right 2, that puts you at a 4. Once again, with this problem, we happen to get lucky. Not only do we find the y-intercept, we also happen to find the x-intercept, which is a nice thing. Questions on that? The other thing you're going to see in this section is I might give you, I don't know, how about 4x minus 2y equals 8. And the directions are find the x and y intercepts. Use them to graph. How do you find the x-intercept?
Okay, take someone by itself, someone for that.
That would work. That's too hard. There's a better way.
Get y by itself.
Get y by itself. That would work too. If I get y all by itself, that would help me find the y-intercept.
Then you plug in for x. You put, yeah. Well, I thought if you had the y-intercept, you'd know the x.
No, if I know the y-intercept,
No,
like
if you have the x-intercept, you know the y, right? That's the-
not always. I mean, here I knew the y-intercept from my equation, but I did not know the x-intercept. I happened to find it by graphing, but I didn't know it.
Should we do that mini table thing?
Do a mini table thing. Okay. I like your idea. I'm going to do a mini table thing. How do you always find the y-intercept? Plug 0 for what? For x. If I ask you to find y-intercept, you plug 0 in for x. So if I ask you to find one intercept, you plug 0 in for the other number.
Same vice versa.
Always vice versa. So if I want to find the y-intercept, I'm going to plug 0 in right there. Well, what happens when I plug 0 in right there? What's 4 times 0?
0.
0. So that piece of the equation goes away, doesn't it?
Yeah.
Now get y all by itself.
Negative 4.
You divide both sides by negative 2. You get y is
Negative 4.
-4. There's the y-intercept.
Can you plug
Yes.
0 into y to get x?
If I want to find the x-intercept, I do the exact same thing, except I plug 0 in for the y number. When I plug 0 in for the y number, that part disappears, doesn't it? Divide by 4, x is 2. There's 0 comma negative 4. There's 2 comma 0. And I draw my line. What's the advantage of doing it that way? I think it's faster and easier. It takes a couple steps for me to do the work to get y all by itself. If I have to do a couple steps, that means every time I do a step, there's a chance I make a mistake, isn't there? But it's pretty easy to just say, well, plug 0 in and get the y all by itself. Not a lot of option to make mistakes there. Plug 0 in and get the x all by itself. Again, not a lot of options to make mistakes.
Could you simplify that equation and then do it too?
I could simplify the equation. What do you mean by simplify the equation?
Get one of them. Just get rid of the numbers in general. So, yeah.
I could take that equation and get y all by itself and then do the same thing. But then that's adding a lot of work, isn't it? Well, not a lot maybe, but some work. It's adding some work to get the y all by itself. And then eventually I'm still going to have to plug the numbers in and work it out. Might as well just plug the numbers in right from the beginning. All right, let's try another one of those. Give me some numbers.
6.
6x. Funny that you both picked the same number. Give me another number.
9.
Plus or minus?
Plus.
Plus 9y. Equals
-3.
-3. All right, you didn't pick the greatest numbers in the world. You'll see why in a second, but that's okay. Same directions. I want you to find the x and y intercepts. Once again, how do you find the y intercept? Plug in x is 0. When I plug in x is 0, this 6x goes away, and I have to divide by 9. What's -3 divided by 9? -1/3. That happens. Sometimes you get fractions. You just live with it. -1/3.
What's the other half of that?
6x. Conversely, what do I do when I want to find the x-intercept?
0.
0 where?
Y.
For y. I always plug 0 in for the other letter. When I plug 0 in for y, I have 6x equals -3. -1/2. I divide 6, -3 over 6. I reduce this to -1/2. The fact that you have fractions, is that a problem when you go to graph?
Can be.
But is it?
No.
You can set it up that way.
Where's -1/2 comma 0?
Halfway between 1 and
Halfway between 0 and -1, isn't it? But I don't have any scaling on my axis right now, do I? So I can just put a dot right here, and I'm going to call that dot -1/2 comma 0. And that's how I get scaling on my axis too. I just label the dot. Yes?
So 9 divided by -3 is 1/3. Is that how you got that -1/3?
We had,
Did you plug in 0 for?
right, so we had 9y equals -3. So I had to divide by 9. So I have y as -3 over 9. And I can cancel top and bottom by 3. Same thing with the y-intercept. Where is 0 comma -1/3?
anywhere.
A little below the axis. So you put a dot a little bit below the axis, and then you say, hey, I'm calling that point 0 comma -1/3. And that suffices. You've told me your x scaling because you've given me an x number. You've told me your y scaling. You've given me a y number. So the fact that you have fractions is only a problem if you've already got a grid drawn and they've already put 1, 2, 3, 4, 5, 1, 2, 3, then it's a problem. If there's no grid marks, you make them up. You put them wherever you want them. They're there. There's my answer. Now, I want to do the same question over again. But I want you to get y all by itself. What would you have to do to get y all by itself? Subtract the 6x. 9y is minus 6x minus 3. And then divide by 9. So y equals, what's -6 divided by 9? You can reduce top and bottom by 3, -2/3 x minus, not 3, minus 1/3. This would be a pain in the neck. Because if I go to graph this, where's the y-intercept? 0, negative 1/3. There it is. Now I have to use my slope. My slope tells me go down 2 over 3. So I got to start at negative 1/3 and go down 2. How far down does that put me? Yeah, that's a pain, isn't it? So this is a very good example of doing it with the...
Be at 1.
What's that? No, if I start at negative 1/3 and I go down 2,
2 and 1/3.
that's going to put me at negative 2 1/3. And then I'd have to go to the right 3. Well, the right 3 wouldn't be too bad. This is a good example where doing it this way is actually a lot easier. Even though you end up with fractions, graphing with the fractions is much easier when all you have to do is mark the intercepts. To try to go down 2 and over 3 from there is a pain in the neck. So sometimes this can work out better. All right, one more. Give me a number.
7.
Oh, you're not going to be happy with that, but we'll live with it. 1/7 x. Told you weren't going to be happy with it. Give me another number. 4. Minus 1/4 y. Oh, let's make it 3/4 y just to make it more interesting. Equals 2. Once again, my directions are find the x-intercept, find the y-intercept. I'm going to draw my little t-chart here. What would you do to find the x-intercept?
Plug away.
Plug away what?
0.
For?
0 for y.
Because I asked you for the x-intercept first. I changed my order. You plug in 0 for y. If I plug in 0 for y, the y part disappears. How do you get the x all by itself?
Multiply by 7.
Yeah, you just multiply by 7. That fraction's not so big a deal anymore, is it? Multiply both sides by 7. X is 14. You get a pretty big x-intercept, but that's okay. How do you find the y-intercept? Plug 0 in for x. When I plug 0 in for x, that part goes away. This one's slightly harder. How do you get the y all by itself? You got to multiply, not add, you got to multiply, because this is connected by a times, isn't it? So to get rid of a multiply, we do a divide, or since this is a fraction, we can multiply by the reciprocal. All right, so I'm going to write this one down. If we have minus 3/4 y equals 2, we would multiply by minus 4/3. Because then the 4's cancel out, the 3's cancel out, we're left with y equals negative 8/3. So that one turns out to be a fraction, but that's okay. It wasn't horrid. All right, now we graph. Where's 14 comma 0?
Anywhere.
Well, it's not anywhere. It's not here, for example. It's somewhere on the x-axis over here, isn't it? Pretty far to the right. There's 14 comma 0. And where is 0 comma negative? Somewhere down. And again, it doesn't really matter where you draw it. You can draw it pretty much anywhere you want. I'm going to put a dot right there. And I just label it as 0 comma negative 8/3. Helps if you can see. Connect my dots.
If you were to simplify that fraction, would that be allowed?
What do you mean by simplify?
Turn it 2 and 2 2/3.
That's not simplifying, but yes, it would be allowed.
Okay.
That's writing it as a mixed number.
Yes.
And easier to put on.
That way you know.
It would be a little easier to put it on the graph, probably if you wrote it as negative 2 and 2/3, you would know you want it down close to negative 3. But since I don't have anywhere where negative 3 is marked anyway, it doesn't matter. I just put a dot and label it and I'm good. Questions?